if my 3 is in my denominator, I'm going to put a 2, 3, 4 on top of it. It goes 2, 3, 4. For 4, it's going to go 3, 4, 5. And for 6, it's going to go 5, 6, 7. That is half of all of our radian values right there. Now, they're all going to have 1 in front of it. So this must be 1, 2, 4. This is 1, 3, 5. And this is going to be 1, 5, 7. So just knowing that little pattern gets me 3/4 of all my possible radian values, minus my zeros, my pi over 2s, my 3 pi over 4. But anyway, now I just need to get that last value. Well, the top one's pretty easy because it's going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. To get my 4 value, I have to ask myself, how do I get from 1 to 3? Well, that's just adding 2. So to get to 5 to the last one, that's also going to be add 2. So that's going to be 7. My bottom one, to get from 1 to 5, that's plus 4. So to get to 7 from my last term will be plus 4 as well. So this will be 11. And almost all of your radian values are all from there. Now you just got to figure out what order they go in, how to organize them, and I'm going to leave that up to you. I do have a unit circle up there. You should also have your unit circle. That was the one thing I said you should definitely keep. I didn't tell you to throw out anything because everything is important. Trig stuff's always important. But at the very least, I said you cannot throw out your unit circle, so you should have that to check your answers. But like I said, if you want to, you can come up there. And then once you have your unit circle filled out, you have to fill out all these values. I gave you a hint on how to read stuff up there, how to deal with inverses and cosecant, particular cosecant inverses. Remember, when I ask for an inverse of something, the answer should be an angle. When I ask for an inverse of something, so that second one should have an angle. You're just looking for where sine equals 1/2 and go from there. But I'm going to let you kind of stumble through that one asking questions. And then there's some more. You'll see the numbers aren't matching up. I really just copied and pasted stuff just to give you practice. And then you're also going to have to graph. We're not graphing anything weird. We're graphing basically simple sine and cosine ones with small changes. So we don't have to worry about cosecant graphs. We don't have to worry about secant graphs. We don't have to worry about tangent graphs. For this quiz, you just have to worry about sine, cosine, and basic adjustments like going up, down, left, right. And that's all adjusted by here. Remember, your amplitude is that number that's way in front. It adjusts how far it stretches, but it can also flip the graph. If it's negative, it flips your graph. Period. Whatever letter this is, you're going to do 2, or whatever number b is, you're going to do 2 pi divided by that number, and that's going to be your 4th term out. Then you're going to do half, multiply by 3. Phase shift goes the opposite direction you think. If it's negative, it goes right. If it's positive, it goes left. And finally, your vertical shift, if it's positive, it goes up. If it's negative, it goes down. I'm not going to do much with you on this. All I'm going to do is I'm going to graph sine and cosine for you to make sure you at least have the basic graphs starting off points down. All right, sine. Notice there's actually a 1 out here. There's a 1 in front of here. So normally you wouldn't do this, but I'm just giving you a hint for when there's actually a number out there. So since there's a 1 out there, that's actually our b value. So our period in this one would be 2 pi divided by 1, which is just 2 pi. As soon as you know your period, you're going to count out 4 tick marks, 1, 2, 3, 4, and write 2 pi down. So whatever your period comes out to be, count out 4 tick marks, mark it down, and then we go half, multiply by 3. It's not hard with 2 pi because we do it a lot, but half of 2 pi is going to be 2 pi divided by 2, which is going to be pi. Half of pi is going to be pi over 2. And pi over 2 times 3 is going to be 3 pi over 2. Once the period's taken care of, now I just look at all I'm doing is graphing sine. Well, sine starts at 0, 0. There's no amplitude change, so it goes up to 1. It goes back down to 0. It goes back to -1 and then back to 0. And we just got to connect our points. And that is our sine. Our next one's cosine. It has the same period because there's a 1 in front of that x. So once again, we are going to have pi over 2. Pi. 3 pi over 2. And finally 2 pi. Rather than starting at 0, 0, cosine always starts at 0, 1. Goes down all the way to -1. Comes back up to 1 and makes a graph that looks like that. Those are the only graphs I'm going to do with you. Otherwise, go ahead and get started. Ask questions as needed. There's a unit circle up there, but I am floating around to help as best as possible. Try to do as much as you can. Yes?
Can we see our test?